Let's take a look at the limit of the absolute value function as x approaches 0. So this function is not a polynomial, it's not a rational function, it's not a trig function, it's not a radical. I don't know that I can use my substitution method. So I'm going to draw the graph of my function, and I can see from the picture, this is the graph y equals absolute value of x, as my x coordinate gets closer and closer and closer to 0, my y coordinate is also getting close to 0. So this limit should be equal to 0. But let's take this as an opportunity to learn about a different kind of function. I said that the absolute value function is not any of those functions that I talked about on Friday. One of the ways you can write the absolute value of x function is as a piecewise function. So I'll have a different formula depending on whether x is to the left or to the right of 0. So as long as x is greater than or equal to 0, or I might say as long as x is non-negative, the formula for the absolute value of x is just x. If I have an x that's less than 0, though, the formula for the absolute value is minus x. So each of these pieces is a polynomial, right? They're just linear. So how can I take this idea and say that each of the individual pieces lets me do this substitution? Does that or does not that not let me work on the absolute value function? So remember that when we work with a piecewise function, we have to be very mindful of the left and right hand limits. So I can calculate the limit as x approaches 0 from the left, and I'm going to use the function minus x. Right? I'm using this part of the function. And I know, because the minus x function is a polynomial, I can just plug in x equals 0. I get 0. Similarly, if I'm going from the right, as x approaches 0 from the right, I'm going to use the formula x, the formula y equals x. That's still a polynomial, so I can still put in my 0. And the reason I've done it this way is because these are going to be the left and right hand limits, respectively, of the absolute value function. So one thing that's important to remember from last week when we first introduced the idea of limits is that if the limit of f of x, as x approaches a from the left, and the limit of the same f of x as x approaches a from the right both exist, and they're the same, then the limit as x approaches a on the two-sided limit from the left and from the right of that same function f of x equals, well, it's going to equal the left-hand side limit, or it will equal the right-hand side limit. And it doesn't really matter which one I put here because, hey, they're supposed to be the same number. Let's see that in action.